tutor, peer tutor, that asked the question, because I'm like, so do you remember how to do this? So he said, why do we do this? I said, what do you mean, balancing equations? He says, yeah, why do we even do it? So as written right here, this equation, is that possible?
No.
Why not?
Because there's 2 twos.
There's 2 twos?
Yeah.
You look good in a tutu? Bad joke. What do you mean? There's 2 twos.
Those added up would equal 2.
Over here?
Sure.
Be more precise.
There's 2 oxygen on this side and there's only 1 oxygen on this side.
There's 2 O's over here, 2 oxygens, but there's only 1 on this side. So if this happened, what law would we be violating? You're close. The law of conservation of mass or matter, right? So if this were true, we would be destroying 1 atom of oxygen, right? We can't do that. What about the hydrogen? Is the hydrogen good?
Yeah.
The hydrogen is good. So why do we balance equations? Because we want to know how many molecules of hydrogen H2 and how many molecules of oxygen O2 does it take to make how many water molecules, right? This isn't correct. We know that because we'd be destroying some oxygen. In the equation over here, we would be destroying some and creating some. So take a minute, look at this. Can anybody tell me the fix that we would do? I've got one hand up. How would we fix it? Okay, go ahead.
Can I say like on each side?
Sure. How would we fix it?
I think, hypothetically, you put a 2 in front of the water molecule, like a big 2, and then a 2 in front of hydrogen.
Okay, so if we do that, 2 times 2 is 4, so now we have 4 hydrogen atoms, and 2 times 1 is 2. And you went ahead, you saw that you changed the hydrogen, so you went over here and doubled the amount of H2 molecules. Easy, right? Fixed. Okay, what about this one? So I'm gonna let you guys work for a second. You can go ahead and even stop the video. Did you get it figured out?
No.
No, you didn't get this one?
No.
But you got this one. And anybody over here get this one?
Well, I think I got a part of it.
You got a part of it? Alright. So you think you got a part of it. Tell me what you would do first. How would you handle this?
Put a 2 in front of the H2O on the right side. Do that.
Okay.
That's about all I got.
That's it. So let's see where we at. You want to try it? What else are we gonna do?
And O is gonna be.
You gotta put 2 in front of the O2 on the
2 in front of the O2.
Oh, okay.
Oh, I think it's right.
Yes.
Oh, no. You got 1 too many O's. We only have. Is that it? All right, let's see what we got. So, carbon. How many carbons?
4.
4.
0. 1.
1.
7.
1.
Oh my gosh.
Good grief. Hydrogen.
4.
There's the 4. Okay. And oxygen.
4.
4 of them.
4.
4.
Wow, I can't write.
That was
It was getting bad. All right, so same carbon. 1. Hydrogen. 4 right here, and oxygen. 2 here and 2 here.
Oh my
4.
goodness.
Okay, so and remember, if you're struggling with this, something that you can do is just bracket out the molecules like so, and that's going to kind of protect the molecules. You can't change anything in the brackets because those are the molecules. You can't change the molecule, but you can change the what? The amount of them, the number of them. Very good. First period, I had somebody say, well, why don't we just put a number 2 here? Instead of putting the 2 here, we could just put the 2 here, H2O2. It matches fine. What's the problem with that?
It's the same molecule.
Well, it's not the same molecule, yeah. I prefer, when I burn H2 with O2, to get pure water. Because I can drink pure water. Can I drink H2O2?
No, that doesn't sound right.
What is H2O2?
I don't know.
It's if in solution, if you have 3% H2O2 with the other 97% water and you drink a bunch of it, it'll give you a pretty upset tummy. If you drink just H2O2, you're going to die. It's hydrogen peroxide.
Oh.
Details matter in chemistry, right? So yeah, you can't change the molecule, but you can change the number of them to make it not violate the law of conservation of mass or matter. Right? It's important. Now here's a tip when we're doing this, all right? Would it be smart, do you think, would it be smart to bracket these off when we're working so that we know we can't change anything inside of there?
Yes.
Because we've just bracketed off the what? The M word. Molecules. We've said we can't change. What closed that door? Is that door open too?
Yeah.
People are being loud in the hallway. So we bracket off the molecules to remind ourselves we can't change anything about the molecule except the what?
The number of
The number of them. So out in front of each of these molecules, there's a number. And if there isn't, we would just say that it's a 1, right?
Yeah.
So if that's a number 1 out in front of these, we can change that.
Put a 2 over there and a 2 over there.
Put a 2 here?
Yeah.
No.
Okay. Huh? No?
Yes.
You disagree?
I concur.
Put a 2 in front of the H2O and a 2 in front of the H, and then you'll be fine.
So, because we have 2 oxygens on this side and only 1 on this side.
Yeah.
So you're saying put a 2 here.
And then that would make 4 oxygen or 4 hydrogen, and then put a 2 in front of the H.
I mean, I
And
guess
then
that works.
Put a 2 in front of
So we just need to fix the hydrogen. You said put what here?
a 2.
A 2. And now we're balanced. So what this means is we have found the ratio, the smallest numbers, but we could scale this up easily, right? This answers the question of why do we balance equations? Well, this, before we balanced it, is what we would normally say. Hey, you take hydrogen gas and oxygen gas, you react it in a combustion reaction, and you get water. But it's not mathematically correct because you wouldn't be obeying certain laws of physics, like the law of conservation of matter. Because this was a O1 over here, wasn't it? So we would have somehow destroyed one of the oxygen atoms, and you can't do that.
Yeah.
So instead what we've done, we said for every H2 molecule that we want to burn, we would actually need 2 of those. So for every 2 H2 molecules we burn, we need to react it with 1 O2 molecule to get 2 water molecules.
Yes.
That's what you're doing. Now, do that one. Do that one on your own.
Oh, whoa.
Yeah. So we got a refresher, right? We refreshed our minds how and why. Over here we've got methane. Hey, we got methane over here. Everybody, we got methane over here reacting with oxygen. Methane and oxygen burn to yield water and CO2.
Carbon dioxide.
But is that balanced?
Yeah.
It's not possible the way it's written there, so I want you to fix it. Do it on paper. If you don't want to do it on paper, you're going to come up here and do it in front of the class.
That's like a pretty easy equation up there.
It is. It's not hard. If you can do these, you will get a question right on the final.
I got it.
Looks like I'm getting everything wrong, guys.
Most likely sure I got it.
So I'm cooked for the final.
You've still got over what, a
I
week?
gotta do 2 H.
So
He definitely got
carbon 1. Carbon 1. Everybody following along? Everybody following along? You two definitely need to follow along because you missed the whole thing. So H, how many do we have? 4. H. Now that he put a 2 in front of the water, we have 4. And oxygen, on this side we have 4, 2 times 2. And on this side, we have 2 here, and then we have the 2 here. So what we're saying is for that to have methane burn in the presence of oxygen to yield water and carbon dioxide, you okay?
Yeah.
We need, for every 1 methane molecule, Hancock, for every 1 methane molecule, we need 2 oxygen molecules to yield 2 water molecules and 1 CO2 molecule. That's the proportion.
So I got that right?
You did.
No, we got that.
So for every
I'm pretty sure we got that.
You might have gotten it right and wrote it down really wrong.
Yeah. Her handwriting was